this video, we will discuss the problem reverse spiral form of a matrix. So the problem says that we will be given a 2D array and we have to find the reverse spiral traversal of the matrix. So first of all, let's look at what is the spiral traversal of a matrix. So suppose there is a matrix that is given to us that is like 9, 8, 7, 6, 5, 4, 3, 2, 1. Right? If this matrix has been given, that is 9, 8, 7. Right? Then we have been given 6, 5, and 4. After this, when we have been given 6, 5, and 4, and after this, when we have been given 3, 2, and 1 here, right? So when we have been given after this 3, 2, and 1, then the spiral order traversal is that we start from here, right? Then we move down, then we move down. First of all, we start from here, then we move down. So first of all, we write 9, then we write 8, then we write 7. After that, we write 4, then we write 1. Then we move to the left part and we traverse the bottom area. So we basically traverse 2 and 3. Then after that we move up, right? So we traverse 6 and then we move inside, so we traverse 5. So basically spiral order looks like this. We start from the top and inside the top we traverse from the left to right. Then we go to the bottom, right? Then from the top till the bottom we traverse all the elements, and after that what we do is we traverse in the bottom row we traverse from the right to left, and then in the leftmost column we traverse from the bottom to top. And after that what we do is we again start traversing from left in the top row, the new top row, because this top row has already been processed. So now we traverse in the new top row, and what we do is we traverse from left to right again. Okay, then again we traverse in the rightmost column that is available from top to bottom. Then again in the bottommost column, the current bottommost column, we traverse from right to left. Then what we do is in the rightmost column that is available now, we traverse from bottom to top. So on and so forth. We go like this, and we make a spiral form traversal in the given matrix. Right. So this is how we do the spiral order traversal. If you will see this particular case, so you can see that basically first of all we traverse 1, 2, 3, 4, then 8, 12, 16, then we traverse 16, 15, 14, 13, then we traverse 9, 5, 6, 7, 11, and 10. So this is what we do in the spiral order traversal. Now, what the problem is asking is, the problem is asking to give you the reverse spiral order traversal, right? Reverse spiral order traversal. So if this is the spiral order traversal for the given matrix, then what you need to do is, once you find the spiral order traversal, so you just need to reverse this particular spiral order traversal that you have got. So the answer would look like 5, 6, 3, then it will be 2, then 1 and 4, and then 7, 8, and 9. So you can see that it looks like, for this case it looks like 563, then 214, 563, 214, and then 7, 8, and 9. Okay, so this is what has been asked in this particular question. So how can we do it? So basically, if in this particular question, if we will simply do the spiral order traversal for this particular problem, then we will be able to reverse the answer that we have got till now, and we will be able to simply return the reverse spiral order traversal. That is the concept. That first of all, you've on the given matrix, you find the spiral order traversal, and then you simply reverse it to get the reverse spiral order traversal. That is the required answer, right? So how can we do this particular thing? So what we can do is, if we will see, as we have discussed, that we were iterating like in the row. So let's take this bigger example to understand things better. So if you will observe here, so we have been, suppose that we have been given 1, then we have been given 2, 3, then we have 4, then we have 5 here, then we have 6, then we have 7, 8. After that we have 9, then we have 10, we have 11, we have 12, we have 13, we have 14, we have 16, we have 6, like 15 and 16. So if we have a matrix that is containing the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So what we can do is we can use pointer concept here, right? We can have 4 pointers, because if you will observe, we always kept on iterating in the top, then the right, then the bottom, and then the left, correct? So for that we will need 4 pointers, and because what happened was, this was the topmost row, this was the rightmost column, then the bottommost row, then the leftmost column, and then the new topmost row, then the new rightmost column, and so on. So basically for that, what we'll require is we'll require 4 pointers. So what we can simply say is that we'll have a top pointer that will be pointing to the topmost row. So initially we can say that top is equal to 0. Then we will have a bottommost row as well. So we'll have a pointer that will point to the bottom most current row. So bottom, we can simply say that bottom will get initialized to nothing but number of rows minus 1, right? After this, because we are considering a zero based indexing, right? After this, what we can say is we'll have the leftmost pointer that will be pointing to the leftmost column. So left will be equal to nothing but 0. Then we'll have a rightmost pointer that will be pointing to the rightmost column, that is column minus 1, the rightmost column, right? After this, when we once we have these particular pointers initialized, then what we simply need to do is, if you'll observe, so we simply need to iterate. And now, till which time we need to iterate? We need to iterate until the left is lesser equal to the right, and we need to iterate until the top is lesser equal to the bottom, right? Until they cross each other, till that point of time we need to iterate. So what will we simply write here? So if you will consider this part, that we also write the code correspondingly. So what we can say here is we'll simply have a vector, right? Int answer that will be storing the first of all the spiral order format only, and then we'll be obviously reversing this answer. So what we'll say is we'll have a top which will be initialized to 0. We'll have a bottom pointer here. Here we'll have a bottom pointer that will now get updated to nothing but the number of rows minus 1, right? After this, we'll have the left pointer that will be equal to 0, and we'll have the right pointer that will be equal to the number of columns minus 1. Then until which time we need to iterate? So we need to iterate until the top pointer is lesser equal to the bottom pointer until they cross each other, right? So until the top pointer is lesser equal to the bottom pointer, and the left pointer is lesser equal to the right pointer. Okay, that is what we will do, because this is a two pointer approach. You can understand that until the left and the right cross each other, because if they cross each other, then we should not print, right? And similarly, until the top is lesser equal to the bottom, till that point of time we'll keep on traversing. So after this, what we will do, so if you will observe in this particular case, so we will first of all do what? We will first of all print the topmost row, right? We'll print all the elements of the topmost row. So in the topmost row, right, we topmost row is A of top, right? In the topmost row, we'll print all the elements starting from the leftmost column till the rightmost column. So for that, what we can do is we can simply say that we will iterate a loop, like we'll run a loop starting from the leftmost column till the current rightmost column, right? So I start from left, and we can say that I is lesser equal to right. Okay, and then we will do an I plus plus, and simply we need to print what? Simply we need to print this particular thing, that the topmost all the ith elements, that is I, this I, this I, this I, as I will keep on moving. So we need to print all the elements from the left column to the right column of the current top row. So this first portion represents the current row, so the row will remain the same, but the column keeps on changing, so that is why I will be written here, right? And then once we are done with this part, right? So first of all, let's quickly write this part. So what we'll be doing here is we'll say that for int I starts from the leftmost column and I is lesser equal to the rightmost column. Then we will do what? Then we will do an I plus plus. And simply here what we will do is we'll say that answer dot pushback inside our answer, or you can say inside our array list in Java, we'll simply add the topmost row element at the index I, at the column I. Right, now once we have done this, so what should we do? If you will see, once we are done with this part, then the topmost row will change, right? Because when you print this, right, after this, what will happen when you print this area, when you print this, the rightmost, when you print the bottommost, when you print the leftmost, then now this 6, 7 will be the topmost, right? So basically for that, what we need to do is the top row will now be down. So we need to simply say that we will do a top plus plus after doing that, right? So the top pointer will now point here, and we have simply, we can say that we have printed all the elements here, right? So we will do what? We will do a top plus plus here. So what we will be basically doing here is we'll be doing a top plus plus here, right? Once we are done with this part, so now which portion do we need to print? So now if you will observe, we need to print one more portion, right? We need to print one more portion, that is nothing but this particular portion, the rightmost portion, right? So what we need to do here, if you will observe, so now we need to print all the elements in the rightmost column, right? We need to print all the elements in the rightmost column, that are these elements. So in the rightmost column, we need to print starting from the topmost row till the bottommost row, right? In the rightmost column, we need to print starting from the topmost row till the bottommost column. So we need to print all such elements, right? So in that case, what we can now do is we can simply say that for like int, right? I will start from what? I will start from the topmost row, because the now the rows are changing. This will be the ith row, this will be the ith row, this will be ith row, right? So the rows are changing, the column remains the same. So I can say that I starts from zero. Like I starts from top, I is lesser equal to the current bottom, and I plus plus is what I will do. And in the answer, what I will simply add is, like you can say that in my answer, I'll simply push back what? I'll simply push back, or I will add what? I will add simply the A of I, right? Because the rows are changing. This is the ith row, this is the ith row, this is the ith row, and the topmost, the rightmost column elements, right? So that will be nothing but 8, 12, and 16. So that is why I'll write this particular thing here, right? Okay, once I'm done with this part, so you can simply observe that what will happen now is my if I have printed, once I have printed the rightmost column, let's say, right? So once I have printed, like once I have 1 2 3 4 printed, then I'll print 8, 12, and 16. So basically when I have printed these elements as well, so in that case I can simply say that my rightmost pointer should now come inside. So rightmost pointer should now, the rightmost row that is available to rightmost column that is available is this one. So I should do a right minus minus so that the right pointer moves inside. So after this, what I will do is I'll do a right minus minus simply, right? So what we will do here is we'll simply say that after this we'll print the rightmost column. So that is nothing but int I starts from the top. Okay, then I is lesser equal to the bottom. Then we will do an I plus plus here, and what we will be doing here is we'll simply say that answer dot push back. Inside the answer, we'll push back what? We'll push back the uh, A of I, because the rows are changing and the column remains the same, that is rightmost column, right? After this part is done, so we'll simply do a right minus minus so that we can print the rightmost column. Now what you will do is you will simply say that now let us print the bottommost row, starting from the because now we need to print what? 15, 14, and 13 in this particular order. So we need to print what? We need to print the elements in the bottommost row from the rightmost column till the leftmost column, right? So indirectly, what can we say? We can simply say that what we require to do now is we are now wanting to loop from the rightmost column till the leftmost column, right? And we need to print the elements of the bottom row. So you can simply say that what we need to do is we need to say that I starts from what? I starts from the right. Then we need to say that I is greater equal to the left, and then we'll do an I plus plus simply, right? Sorry, we'll do an I minus minus in. Right. So basically, what you can simply say is that inside our answer, we'll say that answer dot pushback, or you can say answer dot at in Java. What we will simply be doing here is we'll simply write a of the bottommost row. The bottommost row will remain the same, and now we will print what? We'll print the ith element, right? So basically, we'll print this element, then this element, then this element. So basically, the columns are changing, and the bottommost row remains the same. But is this the thing that should be done without checking anything? Because if you will observe, if we had something like this, suppose we had a like this thing will work, right? If you will write this particular code directly, if you will write this particular code that is for in I starts from this particular thing, that is the rightmost pointer, the rightmost column, and then you will do I is greater equal to the left, and then when you do an I minus minus here, right? So when you will do this particular thing, when it will start from the rightmost and it is going till the left, okay, and when you are doing an I minus minus and you're printing the bottommost rows, so what you will do is you'll simply say that answer dot push back, we'll simply say that answer dot push back A of top, right? We'll say, sorry, we'll say that A of bottom, and we'll print the ith element for all this, right? For the columns we are changing. Now after that, you will say that once we are done with this, so we need to do what? We need to print the we need to make the bottom pointer move upwards. So we'll simply do what? We'll simply do bottom minus minus so that the bottom pointer moves up. But should you directly write this particular case? No, because you need to understand one thing, that you should check that whether they cross each other or not. Because if you will consider a basic sample example, let's say if you have 1 2 3 4 5, this particular example, like whenever the number of rows inside are odd, then this will not work directly. Because what will happen is if the top is pointing here, right, if the right, then the right will also point here, because this is the topmost row as well as the sorry, if the top, this is the topmost row, okay, and this is the bottommost row, right? So whenever the number of rows are odd, then you need to keep a check. Why? Because if you'll observe, if this is the topmost row and this is the bottommost row, okay, so in this like if the topmost and the bottommost row is the same, basically when there is only one row, or let's say there are odd number of rows, right? Suppose that the things were given and somehow now the top and bottom are pointing to the same point, Okay, if there is an example. So in that case, what you will do, you will simply say that, let's say you will print the topmost first of all, right? So if you consider this example that has only one row, so basically I'm considering the examples in which there are odd number of rows. So I'm not making a bigger example of 5 rows or 3 rows. That will take some time. So if you will understand this, that will be better. But you can understand that if we have 1 2 3 4 5 6 7 8 9, right? So you can see that this will be the top will be printed first, then the top will move down here, right? Then what will happen, you will have the bottom, so bottom will be printed, and after that bottom will point to the same, right? So whenever the odd number of rows are there, then the top and the bottom, after a certain point of time, they will be pointing to the same particular row, right? Because the top was initially here, the bottom was initially here. When you printed the top, then top moved down here, and similarly the bottom moved up here, right? When you printed the bottom as well, right? So you can understand that when the number of rows will be odd, that at one point of time the top and the bottom, in the starting of the loop, they will be pointing to the same pointer. Then what will happen, you will simply print all the elements of the top row, right? Starting from the left till the right, you will print all the elements of the topmost row. Right, then what will happen? You will move your top pointer down. So top pointer comes hypothetically here, and bottom pointer is still pointing to this particular row. After that, what you will do is you will print what? You will print starting from the topmost row, right? After printing the top, what you will print? You will print the elements of the rightmost row starting from the top till the bottom. So the top, if you will start your I from the top and I is less or equal to bottom, so nothing will get printed after that. So there's no right portion that needs to be printed, and you can see in this example as well. After this, what you will say is you will say that now like now the right pointer will move inside, basically you will think of that, right? And then you will say that now you need to print all these elements, right? You need to print all these elements, because you will say that now in the bottommost row I need to print from right to left. Okay, you have already printed 1 2 3 4 5 already, but now you'll say that I need to print what, 4 3 2 1, right? You will say this thing. But do you actually need to do this? No, because these elements are already printed. So you need to check that if it was happening, right? If it was happening, that if the top is lesser equal to the bottom, right? Because you can see here that should not be done, because basically you can observe that the top has crossed the bottom. Then if the top has crossed the bottom, then you should not print the bottom most row, current bottommost row, right? Because if the top crosses the bottom, then if you print the bottom again, so basically the top must have already covered that particular row, and you are still trying to print it here, you can see. So basically we need to put a condition that if the top is lesser equal to the bottom, right? In that case only, when the top is lesser equal to the bottom, in that case only we will be printing the bottommost row, current bottommost row. Okay, we need to keep a check on that. So that is what we will do. So suppose that after this the bottommost is also printed. So basically when these elements are also printed, after this particular part is done, so what will we do going further? Now our task is to print what? Our task is to print the current leftmost. So after this, what will happen here is now our bottom comes up. So now the bottom pointer comes here, right? The bottom pointer comes here. You can understand that when the example was 1 2 3 4 5 6 and 7 8 9, then the top would be pointing here, right? Then the bottom was here, right? Then after that, what happened, when you do when you print the top, then top pointer comes here. After that, after certain point of time, when you print the right, then you print the bottom as well. So then what happens, the bottom also comes here. So the top and the bottom will be pointing to the same row if the number of rows are odd after a certain point of time. And then you can observe that when the top is here, bottom is also here after certain point of time. After that, the top will print this row, right? So top will move down, and the bottom, now the bottom, you will try to print the bottom row also, but you should not print the bottom row because this particular row has already been printed. So that is why you should check that if the top does not crosses the bottom row. Okay, after this part, what you will do is you will simply want to traverse what? You will simply traverse from bottom till the top, right? So you will see that for I starts from the bottom. Okay, I is greater equal to the top, and then you will do an I minus minus. And what you need to do here is you need to simply print all the elements. You will say that answer dot push back, right? What you will push back here is will push back simply all the elements of the ith row, because this is the ith row, this is the ith row. So all the elements of the leftmost column, right? All the elements of the leftmost column. So you'll say that if I left is what you will print. But here also there is a catch. Suppose that if we talk about a particular scenario here, in which the number of columns are odd, then also this situation will arise. Because if you consider the example 1 2 3, right? You consider 4 5 6, you consider 7 8 9, right? So currently this will be the leftmost row, this will be the leftmost column, and this will be the rightmost column. So when you print the leftmost column, right, then what will happen, the leftmost column will come here, right? After that, when you print the right here as well, so right will also come inside, so right will come here, right? After that, what will happen, you will print the left. So when you will print the left, So now the left pointer will move up, and then so basically if you will now try to print the right, so it should not be done because the top must because the leftmost pointer must have already covered this particular column, right? So you don't need to print it up. That is the thing here. Basically you can understand once again, if the left was here, right, initially the right was here, the left most column pointer and the rightmost column pointer, then when you print the leftmost like when you print the right column first of all, so the right will come inside, the right will come here. Okay, simply after some certain point of time, when the left is also printed, the left will also come inside, so left will come here, both left and right are pointing to the same. Then after that what will happen, the left this particular thing will be printed, and the right comes here. Okay, and then the left is still remaining here. Now will you print the left again? No, because the right pointer must have already covered this particular column, so you don't need to print again, right? That is the thing. Because if you want to consider a simple example, so let's consider an example which consists of only one row, so that things will be better explained. So if you consider this particular example, let's say, so here the top will be pointing here, the bottom is going to get pointing here, right? This is the left where it will be pointing, and this is the right where it will be pointing. So you can check this example for all the odd number of columns as well, right? So what you will do is, first of all, you will print the top row. So you print this element, right? So then what happens when you printed this element, then the top moves here. So already you have printed one, right? You have printed this element. After that what you will do is you will print the rightmost column, right? So when you print the rightmost column, then you will print what? You will print two three rows starting from the topmost row till the bottommost row. Okay, you will print all the elements. So basically you have traversed like this, and you have traversed all the elements here. After this what will happen here is you will move your right pointer inside, so the right pointer comes here. Okay, and then you will try to do what, if you have done this thing, now you will try to do what, you will try to print starting from the right till the left, but right is greater, since the right if you will try to print now from the right to left, so right is what, the right and left have crossed each other, so you'll not print anything. You have printed this, you have printed this, but there's nothing that needs to be printed here. After this, if you will observe, so then you will try to print what, then you will try to print up, right? But if you will try to print up now, so that is actually not possible, because after that what you will do is you will print move your bottom here, right? Then if you will try to print the leftmost row, if you'll try to print this particular row, so that's actually not possible, because the leftmost row has already been covered. If you consider to print again, so you'll print the elements 3 and 2 again, but they have already been covered. So you will do what, you need to check this particular condition, that if the left is lesser equal to the right, only then you need to print, right? If the left is lesser equal to the rightmost column, then only you need to print. So what you will do is you'll simply say that for int I starts from nothing but the current bottommost column. Okay, then I is greater or equal to the top, and then we will do an I minus minus, right? And after this we'll simply say that answer dot push back. We'll simply say that answer dot push back a of I and the leftmost row. Okay, now once we are done with this part, so our traversal has been basically done. And once our traversal has been done, so we will be simply storing what, we'll be simply storing all the answer, like you can understand. And after that what will happen, after that these elements will be printed, so you can understand that 1 2 3 was 1 2 3 4 was printed, then 8 12 and 16 will be printed. After that 15 14 and 16 will be stored in the answer. Then what will happen, 9 and 5 will be stored. After that again we'll print the topmost, so we'll print 6 and 7, right? So 6 and 7 will be printed. And after this we'll print this particular row, so 11 will be printed, this particular column, then 10 will be printed. Okay, after that when we will move up, so nothing needs to be printed. So basically you can observe that when we have covered the traversal like this, the spiral order traversal, that is topmost, rightmost, bottommost, leftmost, then we move up, then we move here, then we move here, right? So when we have done the spiral order traversal in the end, so we need to simply need to do what, we simply need to reverse our answer. So we'll simply do that, reverse answer dot begin, comma, answer dot end. Okay, that is what we will do. We'll simply whatever we have printed, whatever we have got in the answer in the spiral order format, we need to simply return the reverse spiral order. So we'll simply return reverse our answer, and then we'll simply return it. Let's try and compile this to see if it works or not. Okay, so we are not getting the expected output, I think. Okay, yeah. So yeah, here what we must be doing is, once we have printed the leftmost, so we should do a left plus plus also, right? So the left pointer moves inside. That is what we were forgetting, like as we have done for all the other pointers, right? So now we'll compile submit this question, and let's see if it works or not. So you can clearly see that this particular approach is able to get submitted, right? For it is working for all the given test cases. Not talking about the time complexity of this particular approach. Okay, so if you will consider the time complexity, so the time complexity of this particular approach will be what? It will be nothing but order of n cross m, because we have iterated, or you can say order of r cross c in the questions language, because r and c are the number of rows. So basically, the time complexity you can say as order of n cross m, right? Or r cross c in this particular case, if number of rows is r, number of columns is c. So basically, you can say it will be n into m kind of thing, right? Because we are iterating we are traversing each cell exactly once, right? We are visiting each cell exactly once. And if you talk about the space complexity, so since we are using pointers, we have not taken any extra space except for the fact that we are returning the answer. So you can say that the space complexity will be order of 1 if we do not consider that we are taking extra space for returning the answer, right? Other than this, we have not taken any extra space for any data structure or anything. Let me walk you through the code again. Right, so again you can see the topmost pointer was the topmost row was set, the bottommost row pointer was set, the leftmost column pointer and the rightmost column pointer. Then we iterated until they crossed each other, right? And then we printed first of all the topmost elements of the topmost row, and then we did a top plus plus. Then after that, what we did was we printed like this is when we'll print the current top row, right? This is when we'll print the current top row. Okay, after that, what we did was after this we'll move our top row down, and then we also need to print what? We also need to print all the elements, right? We also need to print all the elements of the current rightmost column, right? Rightmost column. So we'll print all the elements of the rightmost column. Right, after doing this, what we needed to do was we needed to check if in case of odd number of rows, in case of odd number of rows, we need to check that top is less or equal to bottom. So after checking that, we'll print what? We'll print the elements of the bottommost row, right? If the top has not crossed the bottom, so we'll print the elements of the bottom row, current bottom row. And after that, we also needed to check if the left does not crosses the right. If that is not the case, then we'll print the elements of the left row. Okay, that is how we did it. So if you understood this particular explanation, make sure to hit the like button and comment on understood as well, and also subscribe the channel. Thank you for watching this particular video.